1, 0, all engine running. Liftoff, we have a liftoff. You're on the ground, you got a bunch of guys about to turn blue, we're breathing again. Okay, Neil, we can see you coming down the ladder now. I'm at the foot of the ladder. It's one small step for man.
What I do remember about the first one was just how disappointed I was. Very grainy image of a man walking down a ladder. I couldn't really get it. I didn't really understand.
Today, we have the privilege of speaking with Professor Andrew Dempster, Director of Australian Centre for Space Engineering Research at UNSW, a leading expert in space systems and satellite communications.
Money is always a problem in Australia. The space agency as it is right today is not what we need. The Labor government has been absolutely terrible. The space agency can be very proactive, very successful without a lot of money. If you want to work in space and you want to work in Australia, it won't happen.
If we do succeed in extracting resources from the moon,
I'd say for Earth, not much.
what do you see as the biggest hurdle in space funding, especially here in Australia?
People would not invest in space in Australia because trying to get investment at that time was really difficult.
If you could wave a magic wand and solve one major problem in space exploration, what would it be?
Yeah, all the junk in Leo, Starlink in particular.
How do you see the Australian space ecosystem?
We will have a space industry. The major weakness at the moment where we need an agency which is really driving our Australians' space interests.
Hey all, welcome back to Spacefront Conversation. Today we have the privilege of speaking with Professor Andrew Dempster, Director of Australian Centre for Space Engineering Research at UNSW, a leading expert in space systems and satellite communications. Professor Dempster shares his unique perspective on the evolving space startup ecosystem, the challenges of innovation in the sector, and his vision for funding next-generation space ventures. Professor Dempster has been at the forefront of Australian space engineering for decades, from developing some of the first locally made GPS receivers to leading CubeSat missions and pioneering space resource research. Professor Dempster, welcome to the show.
Glad to be here.
Yeah. So, Andrew, I would love to start at the beginning. When you looked up at the stars, did you ever imagine you would one day be leading a center like Australian Centre for Space Engineering Research?
Short answer, no. But I think what happens is that there's a lot of romantic language used around space, which I don't necessarily identify with. But in terms of looking up and being interested, I'm of that generation. So I am old enough to be around when the moon landings happened. And what I do remember about the first one, Apollo 11, was just how disappointed I was, because I was 6 years old, used to watching cartoons and spacecraft flying around in fictional things on the TV, and then this very grainy image of a man walking down a ladder, everyone in the room getting very excited. I couldn't really get it. I didn't really understand. By the time Apollo 17 came along, I do remember standing outside my house in Queensland at the time, looking up at the moon and thinking, oh yeah, there's someone, or there's some people standing on that. And that was, I found that quite engaging. But I've really been attracted to space because it's hard, I suppose. You know, it's a challenging thing. The romantic side I'll leave to others. In terms of running the centre, my research at the time was largely in satellite navigation. And it was the Dean of Engineering at UNSW who came and said, look, you've won this money for this project. Why don't you set up a centre? So it wasn't my idea. I was just following orders.
So, I mean, like, how did you get that idea of, starting this Australian Centre for Engineering Research?
Well, the project we were working on at the time was in three parts.
Mm-hmm.
The first part was to look at synthetic aperture radar on satellites. There was a part where we were building a new GPS receiver for space, and another part of it which was reflectometry. It's a type of remote sensing that uses the satellite navigation signals, like GPS signals, reflected from the Earth, and then you can infer something about that reflection point. So if you treat the radar idea as space missions, then all three of those
Mm-hmm.
things that we put forward in that project, and so all three of those research areas we're still working on. So at the time, the Dean saw that work we were doing and suggested, why don't you create a centre? And that's where that idea came from.
It's amazing to hear how those early moments shape, career path. And was there a defining moment in your career, say an aha moment, that really set your path on space engineering?
Well, probably not. But one thing about being in the research business is that those aha moments or eureka moments are fundamental to the way a researcher goes about their business. So in the Faculty of Engineering, we run a course which instructs PhD students about how to go about doing their research degree. And I set that course up a long time ago, but there's only one lecture that they let me do anymore. And in that, I talk about novelty. How do you express new ideas, and where do new ideas come from? And one thing I say to students in that is that they may be at the university for 3.5 years doing their PhD, but the most important thing may just take seconds. That aha moment. Now, in terms of my own career, that has into the space business. It's been much more gradual. And what happened, the moment, if you like, that got me into the business was I actually got poached by a company in Canberra called Space. And I had been working for a telecommunications company in Sydney, and there was a family connection, and one of the people from that company said, would you like to come and work in space? And I did sort of take that job because I thought it sounded challenging. And so I started working in space projects early, and then that company started looking at GPS. And at that point, well, I worked there for a while, then went off to do my PhD and so on. But most of what I've been doing has been sort of space related.
I think those turning points can really change everything.
Yes. So basically those two that I've mentioned so far, where the Dean and this other person approached me, it's been someone else tapping me on the shoulder rather than any great insight on my part.
Yeah. So if you had to summarize your journey in just 3 words, what would they be and why?
Yeah. Okay. So I think specifically when you talk about space, I think one of the words has to be difficulty. One, because what you're trying to do is difficult, space is hard, all that sort of stuff. But trying to do, in the time frame that I've been working in space in Australia, it has always been difficult. And it has improved. It's much better now than it was. And I had a saying, which I haven't used much recently, but certainly in the early days of my centre, I had a saying which was like, oh, yes, don't worry, it's just another crisis.
Yeah.
That there would always be something, we would run out of money. And money is always problem in Australia. We'll probably get onto this later when you want to talk about startups and so on. But space has not been something in Australia that either the government or investment bodies have supported very well. So that's one word, is difficulty. Another word I think has to be people. There's been quite a lot of good work done by my centre, and I claim credit for that only in the sense that I've recruited good people. Another little saying I had was, always try and recruit people who are better than you at doing what they need to do. Which is good and bad. It means that I can't help because they're ahead of me. But I've had a lot of good people along the way who've done some really good things. So the third word is success. Now, that's not saying I necessarily consider myself to be a great success in this area, but I have lived through the period, and people who are in the space business, say 10, 15 years ago, have a great deal of satisfaction that, for instance, the Space Agency has been set up. The Australia now has a Space Agency. The Space Agency as it is right today, 2025, is not what we need. The Labor government has been absolutely terrible in the way that they've treated the Space Agency. The Space Agency as it is at the moment is a regulator, and what it needs to be much more proactive. Now, other people will say, oh, we need to have lots of money for the Space Agency, but I've got some hypotheses I'm going to try and test before the end of the year on how a space agency can be very proactive, very successful without a lot of money. And in fact, I think a lot of that evidence is already in. So, and you look at where the industry is, the sector is now, compared to where it was 15 years ago when I set the centre up. In those old days, you would not recommend to a kid going to university, go and do a degree that, if you want to work in space and you want to work in Australia, it won't happen, right? You've got to either do a different degree if you want to work here or go somewhere else if you want to do space. That is no longer the case. There are many companies now, companies that didn't exist 15 years ago, who can employ people with those qualifications. However, one other piece of advice for those people considering going to university is they often do not recruit aerospace engineers. They want someone who can do the electronics. They want someone who can do the structure, the mechanical side of things. So the idea that an aerospace degree is the right degree to get you into space is also not necessarily true.
I agree that.
Anyway, so I think the word success, I think, despite the fact that we've had some setbacks over the last couple of years, people who are disappointed with that, I just point 15 years back and say, look where we were then, look where we are now. I think we're in a much better place.
I really love that. It captures a long journey in a simple way, the way you explain. Yeah. So now something I find really interesting is your innovation. I think innovation isn't just about technology, it's about people. How do you cultivate curiosity and creativity within your teams?
Yeah. So I've had a number of teams doing various things over the years. And I think your question is sort of about management style. Now, I don't know whether my style is good or otherwise, but I do tend to be fairly hands-off. I suppose I do throw people in a bit at the deep end. There's a fair bit of support around within the groups that I have, but I do expect people to get up to speed quickly. The other thing which I learned when I was at Auspace, because when I was at Auspace, I did actually manage a team. It was quite a big team at one time. When we were developing the GPS receiver there, the biggest the team was 10 or something, 12 maybe. which for that job was relatively big. What I've liked to be able to do, and I think something which is important that I don't really hear people talk about very much, is the ability to absorb pressure. Now, in an environment where everyone is on timesheets, and every hour has to be allocated to a project or whatever, there's a fair bit of pressure coming down from the company's management to deliver the project on time, on schedule, on budget. And I think one of the university has a similar but different environment. I think what you really have to do as a manager in those situations is absorb that pressure and only pass it on in such a way that encourages the people, because both in that company environment where we were developing the GPS receiver and in the research environment, you have to allow the people who are doing the work to be creative. I mean, I think engineering is actually quite a creative job. I notice in myself that if I'm actually doing research, which doesn't happen very much anymore, I have less interest in doing other creative things like writing or doing artistic things, right? That research is exercising that part of my brain, which, a creative person would use for something else. So you've got to allow the people who are doing the work to be able to exercise that creativity. So, keep them moving, but absorb some of the pressure. I think earlier on I didn't do that very well. And I think that's something which I've tried to learn over the years.
I think behind every system, every project, every satellite, there is definitely a team making it happen.
I think the team element of it is slightly different. And there are elements of introversion and elements of on the spectrum for people in engineering in general, but certainly the bits of engineering that I'm most involved with, which is sort of the electronics and computer science, they're often quite individual. People who are, they're interested in socializing, but they're also quite happy in their own little space. So also getting a team to work that is made up of those sort of characters is also sometimes interesting.
Yeah, it is. So can you share a project that did not go as planned and what it taught you about resilience?
Yeah, I'm not sure I learned a lot about resilience, but it's just another crisis. But that project, for instance, working on the GPS receiver at Space, we had lots of nice discipline with project management, system engineering, all that sort of stuff, work breakdown structures, and we had all the tools to make the project run smoothly. But in order to deliver a project on budget, in particular, but the schedule as well, is that you need to be doing good estimates at the beginning. So the GPS receiver we were developing had a hardware element, had a software element. We did all the estimates for all the work, and hardware element exactly to budget. Hardware finished, no problem. Software went over by a factor of 3 or 4, something. And that was very difficult. I remember one day at that place, and the EA, the company manager, the CEO of the company, came to me and said, "Right, boss wants you in his office." That's right. Okay, right. I'm going to get the sack. Right. So on the way walking to the office, I'm thinking about, right, where can I go and work now? And he pulls me into his office, sits me down and goes, right, we're thinking of getting you a company car. It's like, what? So that was, I think I was sort of thinking that things might have been worse than they actually were. But possibly that point I was making earlier about absorbing pressure and not passing that on to people who are being creative, I think that's probably the biggest lesson I would have learned from that.
Yeah, I think failure in space is tough, but those lessons are often valuable.
Yeah.
Yeah. So, after decades in this field, what still drives your passion for space innovation?
Well, after decades in the business, I'm sort of winding down my involvement in the business. So space is the subject matter, and research is what I'm trained for, or what I do. And to be honest, what I find interesting about this work is that the development of new things, the novelty, coming up with new ideas, and being challenged by new problems. One area that we work in is space resources. So looking at how you might, say, extract water from a regolith on the moon. And you think, oh yeah, that sounds like an interesting, you just have to get some soil and you process it and whatever. And you think it's it might be, the discipline you need to be able to work that out might be, say, chemistry or something. But what we found with that work is that we collaborate with people from almost all the faculties at the university. So the law around space mining isn't settled. The people that tell you it is, do not believe them. The most developed law at the moment is the Artemis Accords, which is simply bilateral arrangements between the US and everyone else. And there's no real guidance how that law would be enforced, or who's responsible and this sort of thing, and who has jurisdiction. So on the law side and the regulation side, people are thinking about it. Clever people are thinking about it. There's the relevant committee in the UN is co-chaired by an Australian person. So the law is not settled. The business cases are not settled. How do you, if you're going to do this thing, how do you make money, and how do you convince someone to invest in this? Say you're going to turn water into hydrogen and oxygen for rocket fuel, then you will need a customer. In other words, someone needs to put something on the moon or around the moon with the relevant interfaces so that you can fill it up with the relevant fuel. But also, they need to have the confidence to be empty at that point so that it can be filled up. Right? So the customer needs a lot of reassurance and a lot of de-risking. But then why would you do that if the customer didn't exist? So the customer will not exist without the supply, and the supply will not exist without the customer. So there's going to have to be a fair bit of bootstrapping and all that sort of stuff in order before business cases get settled. Ethics. Is it an ethical thing? So the humanities department gets involved. So for an instance, an ethical argument is if you start mining in space, then you're undermining some environmental arguments on Earth, right? So some of the environmental arguments you can make say, look, we've got limited resources on Earth. We should be much better about them. If we diminish the resources, then, or if you consume the resources at a rate faster than they're being replenished, then we're in big trouble. And so we should change our behavior in certain ways. But if you then say, look, we can mine in space, we've got infinite resources, then you can't make that argument anymore.
Yeah.
So I would imagine most of the people you talk to about space are interested in the engineering and science and that sort of stuff, which of course is very fundamental to being able to do that. But all the disciplines around it, all the social license needs to be dealt with as well.
Yeah.
I think your question was about what
How-
drives me, right?
Yeah.
So this idea of being able to collaborate and communicate with all these different disciplines, I find that very, very interesting.
Yeah, I think an individual needs motivation, and staying motivated for such a long period is really difficult.
Yeah, or you can
Yeah.
just retire.
So, GNSS receivers are everywhere today. But what's the story behind building one from scratch here in Australia?
So we're talking late 80s, and at that time, the constellation of GPS satellites, and really we were just talking about GPS at that time. Now there are 4 global systems: GPS, Galileo, GLONASS, Theta. Lots of regional systems, other systems, low Earth orbit systems. There's lots of other stuff now. But then there was just GPS. You couldn't use GLONASS because they had not released their signal specs, so you couldn't design a receiver for it. But the constellation was not complete. So when we designed our receiver, we had to go out at 4 o'clock in the morning to try and get the satellites, because that's the only time of day when enough satellites were visible to us to be able to get a position. Also, we didn't have any radio frequency test equipment in the company, and we could borrow some from a nearby University of Canberra. But we ended up designing our, looking back, I don't know how we did it, to be honest. We designed our whole front end without any test equipment. And what that meant was that that everything had to work before we could say that anything worked. And what it is, so the GPS signals are actually below the noise. So if you just put an antenna outside and look at the sky and look, the band where GPS is, you won't see anything because it's below the noise. You've got to process it in such a way that it pops up. And getting a bit technical, we were actually taking 1-bit samples of the signal coming in out of the antenna and processing it in such a way that it would pop up. Personally, even though I was running the show, I'd seen the maths, I was the project manager and system engineer, I didn't believe it would work. So I didn't believe it would work until it worked. So I don't know, most people won't get the 1-bit sampling thing, but that's, yeah. So anyway, so we've moved on a long way from there. We've now into the 5th generation of receivers that we're putting into space. So things have changed since the 80s.
I think that must have been a challenging task for you.
Yeah, but again, see, the thing is, and this I think is there's probably lessons here for Australia. Is I had great engineers on that project. Really sort of lateral thinkers. How do you design a front end and test it without, test equipment? And that is also part of what makes the experience enjoyable is, you're in a team of really good engineers, which we produce at a relatively high rate. Australian engineers' qualifications are great. The people who do it are great. I just don't think there's enough challenging work like that for the engineers. They might end up becoming managers. I used to have those statistics for the UK, that the number of engineers who are on boards of companies, very, very large number. So they've gone the management route because they're organised and whatever. I think a lot of the, if we could exploit some of our engineers more technically, I think that would be great. And again, I think possibly that comes back to some of the arguments later about how to get a technical company going in Australia.
Yeah, agree. So, how do you see satellite navigation evolving over the next decade beyond what we know today about GPS?
Yeah, satellite navigation's not in a good place right now. You look at what's happening in Ukraine, the Middle East, those areas are now sort of no-go zones for the GPS and other satellite navigation systems because they're being jammed, they're being spoofed. And to be honest, apart from defence, and even defence hasn't given this enough priority, the problems with if GPS or GNSS is not available, then what? What do you do? There's not been enough thought about the resilience that's required. There was a study done more than a decade ago in the US that showed that all of the critical infrastructure sectors in the economy rely on GPS, mainly for timing, because they're atomic clocks orbiting the Earth, and they allow us to distribute time around the world, but also for positioning it somewhat. And the fact that the whole economy sits on GPS should have caught our attention earlier. I mean, the first workshop I ran in Australia on the vulnerability of GPS was 2005, so 20 years ago. And it's only now with these wars that things are becoming very obvious. The 3-month period last year, 140,000 commercial airline flights were interfered with by other jammers or spoofers. 2025 had 4 times as many reported jamming incidents as 2024. So yeah, satellite navigation is in a tricky place right now. There are new systems coming along. So the satellite navigation systems we know, GPS and GNSS, live at medium Earth orbit, so 20-something thousand kilometers away.
Yeah.
New systems are being introduced at LEO, low Earth orbit, so just hundreds of kilometers away. They will have orders of magnitude more power, so they'll be harder to jam, less vulnerable, but they'll bring their own problems. Working in LEO is problematic because it's getting so crowded, other problems. But in the short term, if you're saying about what's going to happen in the future, I'd say that probably either standalone LEO systems or Galileo, the European system, is talking about having MEO in LEO. They've also got geosatellites, but talk about that right now. So I think that's one thing. There are solutions being proposed for space. Other PNT type solutions like using quantum sensing, gravitometry, for instance. I think they bring their own vulnerabilities, but they are really quite orthogonal alternatives. The problems with that are completely different than the problems with this. If you're talking about jamming as being a problem for GPS, then any replacement for that, which requires radio signals, can also be jammed.
Yeah.
So, it's the same problem, just implemented differently.
Yeah, I think a lot of people think GPS is already solved, but clearly there is much more to work around it.
Well, there's a number of problems with GPS. It's in your pocket. You use it to navigate all the time. I used it to find this studio. So people firstly think it's everywhere all the time. second, if they think about it at all, they think, oh, okay, it's provided by the US military, bulletproof, it's, nothing wrong with GPS, and those assumptions are not
Mm.
valid.
So, can you share a moment where your technology made a real world impact, maybe even in a way you did not expect?
I've probably worked in 4 different research areas over the years. So when I did my PhD, I worked with shift and add multiplication. So it was to do with how you can minimize the amount of hardware, but also power consumption of multipliers in chips. But then the methods I was talking about really were drastically useful in digital filters. So anytime you're filtering a signal in the digital domain, you can make quite a lot of savings. Now this basically because I did my PhD at Cambridge, right, and in the signal processing group. So they were doing all sorts of high-powered mathematics and stuff, and I was doing adding and subtracting. You can save effort doing that. So in my group, they all thought, oh yes, this is not very difficult and whatever. But the paper that I published in my PhD has been cited over 500 times. So it's obviously been used a lot. The techniques that I've come up with have obviously been used a lot in chips, and I would imagine also, I would be surprised if we are not carrying around in our pockets the results of some of my algorithms. And, the guys who laughed at my adding and subtracting, none of them have a 500 citation paper. So anyway, I then moved on. And so I had a friend who was, when I was doing my PhD, he was doing malaria. He was looking into malaria, completely different subject. And we were just sitting down having a drink one day. Why don't we do, what can we do together? So we thought, well, what if we did image processing of because you look at it through a microscope. He was looking through a microscope, trying to find the malaria parasites in blood. And so we started looking at this, and I had there's a particular type of image processing called morphological image processing, which is all about shapes, and you can sort of try and match shapes up. But there's really quite complicated mathematics that's behind it, but it's also relatively intuitive. You can get it by looking at it, which I like as well. So anyway, we came up with a whole bunch of ways of doing this, and so they could run lots of images with these algorithms and identify whether there was malaria present in the blood. So that then, when I left my university in London, Westminster, I came to UNSW, they took that work and implemented it on a mobile phone. So what you can do now, and in the Sub-Saharan Africa, you can go around, you've got a microscope and a mobile phone on it. You can very simply do this processing where you work out whether very quickly analyze whether people have got malaria or not. On the GPS side, probably the biggest impact is with a company called GPS Systems in Melbourne. They've come up with between us, funded by the ARC, we developed systems which will identify the location of jammers within a meter. So if you've got a GPS jammer around infrastructure like airport, port, whatever, we can say it's in that car. That's where the jammer is, and you can go and find it and deal with it. And that probably was a little bit ahead of its time. It had trouble finding a market early. I think now, though, it's probably going to be, it'll be important in various places. And then I think the impact of the space work has really been in. I run this CubeSat Plus event every year. The first time we ran it was 2013.
Did you see me in your CubeSat workshops or in your lectures anytime?
Did I see you?
Yeah.
Maybe.
I was in your signal processing lecture in your CubeSat workshop.
You were what? 97, 21.
23 in 23.
At CubeSat. But when you say signal processing, what might subject?
Course. Signal processing, some course, because it was one of my electives.
Right.
So you came to me and you saw my laptop, and it was those signal processing graphs and everything was pretty new for me.
Yeah.
And I was like, I had exclamation when you asked me, and I said, I have no idea of the signal processing.
Yeah.
So you asked one of my friends to help me in understanding, and then you left from there.
Yeah. Like the signal processing has been. But anyway, so with the CubeSat event, right, government had at that time a policy that Australia would not launch anything, we would not build anything for space.
Okay.
So the tagline for the CubeSat event was building and launching CubeSats for Australia. And so that's a number of places. So the University of Adelaide and University of South Australia worked together, built a CubeSat. We built a CubeSat ourselves at UNSW, and we built another one with Sydney Uni. So there's 3 CubeSats went up in the QB50 thing. Now those CubeSats were mildly successful. We got some data down. We weren't able to make the payloads do what they needed to do, but the very fact that people in Australia were launching satellites for the first time in 15 years, that helped build the case for the space agency. It's like you guys, the government needs to be thinking about these things. It's going to happen. You can write down your policies as much as you like, but you're not going to stop people from actually getting in space, so you need to deal with it. So that was a different sort of impact.
Yeah.
Sorry.
I think those...
Sorry for not noticing you.
No. It's definitely, those moments must be definitely incredibly rewarding for you.
Yeah. I mean, it was a really really interesting room to be in when Simon Birmingham announced the space agency, because he's education, right? Nothing to do with it. What was he doing there? And he sort of got up at the IAC conference in 2017 and said, "Oh yes, we're just like to host Australia's going to have a space agency, right?" And there was this huge roar from the audience, which is like decades of frustration being, released at one time. And he looked scared, right? He made the announcement thinking, "Oh yes, I'm the hero," and it was like, "Oh, what do I let myself in for?" So it was, and yes, it was. I am not the only one who's very pleased with that.
So now moving from navigation systems to actual missions in orbit, CubeSats are tiny but incredibly powerful. So which mission taught you the most problem solving in space?
Right, yeah. So I'm too old to learn new tricks, but the QB50 satellite that I just mentioned, the UNSW co-satellite, it's called.
Yeah.
And the Waratah Seed satellite that Sydney Uni has been looking after for a few years. Both of these satellites had significant problems on orbit, right? So the QB50 satellite was launched. There was a problem whereby it needed to deploy some dipole antennas so that it could communicate with the UHF on the Earth. And that was supposed to happen automatically. Now, we didn't have a fail-safe, whatever. So that the satellite was orbiting, and we needed to get those antennas deployed before the satellite had any chance of working. we were confident that because it didn't need to deploy its solar panels, we were relatively confident that it would be charging the battery, discharging, and that would be all fine. We just needed to turn this thing on. So the guys that were doing the work were, so this was led as Jun Wayne Chong and Ben South. Well, they did huge amounts of thought experiments and whatever they do, were sort of trying to work out what was wrong, and then how to solve the problem. And what they ended up doing was coming up with a WAV file, so analog audio file, which they then modulated onto a carrier and got it sent up from a 25-meter dish in the Netherlands or something, which transmitted a very strong signal to the satellite, which it could receive using those antennas, which are still stuck to the side of the satellite. So the antennas still worked as antennas, but they were stuck to the side. But you needed to have this very strong signal. Told them to override whatever it was that was causing the problem, and then deploy the antennas, which worked. And then they were able to go on. They also needed in the next part of the process was to try and stop the satellite from rolling in space. So the ACSER system was not working as expected, and the way that they found out, or the problem that they eventually came to concluding in the end, was that there had been a wire. When we deployed those antennas, a wire came in front of one of the cameras, one of them Star Tracker type sensors, which messed up that, and there was no way that software was sort of hardwired, and we couldn't get in modified software to say, okay, well, there's something in your vision that shouldn't be there. So when we took, so what we did was, even though it was tumbling, we said, okay, well, look, they came up with that hypothesis that there's something wrong in the image. They then asked the satellite to send the image down so we could look at it. But we did that when it was over Australia. So that camera took the first image of Australia from an Australian-built satellite, even though what they were really trying to do was to work out whether the imagery was working. So I think the point I'm making, a very similar story goes with RTC, right? There were various problems that went wrong there. And the problem they had there was that a manufacturer delivered something as a flight model that was using different axes to the engineering model. Very poor. There's lots of not very professional people working in the CubeSat business. But I think having really clever people doing these thought experiments and looking at, and they have to be imaginative in trying to work out what the problem is, and do things that are actually not logical. Well, why would that happen? We'll just try it and see if that's the problem. And then you say, oh yeah, right. So you have to be out of the box and not just logically, but you have to be imaginative in how you come up with your solutions.
Yeah, I think I imagine working with such constraints really pushes towards innovation.
In terms of design, how you can design things to overcome the problems that you firstly detect using this method, but also the problems that you imagine, you have to come through. You have to be able to predict all the things that can go wrong, because you can't send someone up with a screwdriver.
Yeah. So if you can talk on your CubeSat projects, what's the most unexpected challenge your CubeSat teams have faced in those initial days of building CubeSats?
Yeah, I'd say it's the same story, the one I just told, which those two things, the failure to deploy and the wire interfering with the image.
Yeah.
And it's that, it's very structured fault tree type reasoning. combined with a little bit of out of the box.
Yeah. As a fact, space always find a way to surprise us. Yeah. So how do small satellites opens up opportunities not just for research, but also for startups and commercial applications?
Yes, and I think Australia is one of the best examples of that. Now, I've got some research hypotheses I want to test at the moment to do with how the Australian space sector has developed in the way it has over the last 10 years. And I'm arguing that most of the success has been in the area of startups. And there's various things that I think you can say about those startups, about how they were funded, how you have to define what success means, and how they became successful. But because I run that CubeSat event, in fact, this is where I started with this whole thing, is that I'd be very interested to start putting numbers against how many of those successful startups were CubeSat adjacent at the beginning, right? So there's people who, like Innovor builds them, but Fleet and Myriota started off with CubeSat platforms. HEO makes CubeSat-sized payloads. Southern Launch, Equatorial Launch, Gilmore, they're all looking at small payloads. Building Space Machines carry CubeSat.
Yeah.
So you've got the CubeSats are playing a role in the majority, I'd say, of successful space startups in Australia over the last 10 years. It's played some role at the beginning. They may have no interest or no activity in the CubeSat area right now. At the beginning, or at somewhere along that path, CubeSats have played a role.
Yeah. So let's zoom out a bit from small satellites to something much bigger. The moon, lunar water, space mining. How close are we really to making this a reality?
I think to some extent we're a little bit constrained because of the way NASA goes about its business. Traditionally in the US, NASA has been sort of obviously dominating how they go about doing things in space. And I think NASA will probably have to get out of the way, because they think about science and they think about, all the airy-fairy stuff they just said about, Artemis, about mankind and all that stuff. Which is completely meaningless. It's colonialism, right?
Yeah.
So I think what's going to happen is we're going to need to have some sort of commercial approach.
Mm-hmm.
You can't stick people on the moon for extended periods and still get funded by Congress, I would have thought, especially given some of the administrations that they've had recently. So, mining is one of those ways of being a bit more financially sustainable. You can do things. Now, some of what you can do with it is again with the rocket fuel. Some of that rocket fuel would be produced in order to get to Mars. So you'd be funding or funded by people like Elon Musk who want to go to Mars. It's a big customer. And if you can start to put together that idea of supply chains and I actually don't think the technology is the real problem. I mean, there's lots of people. If you go to a space resources conference, it's chock-a-block full of people working on the technology.
Yeah.
But there's not a lot of people working on the logistics, the supply chains,
Yeah.
the nuts and bolts that will join all these things together and make it work. If you go to the Space Resources Week in Luxembourg, there's a bunch of space people, not a lot of mining people, and they're talking about, here's my widget that's going to turn regolith into water. Here's my widget that's going to compact regolith so it could be a road, or you can make a blast barrier for launches, and his own launch site. But you got to put all that together. You got to have bigger. It's a system of systems that you're talking about, and there's not enough of that going on at the moment for us to be able to clearly say, oh yes, we can put all this stuff together and we'll be able to get something sustainable by some date.
Yeah, I think there's lot of excitement around this space mining topic, but also a lot of unknowns to work around.
Yeah, no, as
Yeah.
an academic researcher, it's a problem-rich environment, right? So there's lots of interesting things to do. As a business person saying they want certainty, way too much uncertainty for business at the moment.
So if we can carry this further, what lessons from Earth's mining industry translate into planning space missions?
Yeah, look, I mean, some of the things, arose. The strain remote operations, space and alert. I'm not sure if I got the acronym right. There's a few partners in arose who are in the, not so much the mining industry, but sort of the mining services industry. They're the ones that seem to have most of the interesting or relevant work. For instance, if you're operating a mine in northern Western Australia from Perth, or some sort of undersea platform that's in oil rigs out to the northwest of Australia from Perth, there's a fair bit of latency in that control. And obviously, if you're going to try and control something on the moon from Earth, there's a lot more latency. But you can start to learn how you can deal with latency problems. I'm sort of more inclined to think about the other way around, and I think part of the way you would sell space mining to a terrestrial mining company is saying, right, okay, this is what we want to do. See that target way down the track. We want to mine water on the moon, and you should help us, because if we aim at that target, even if we never get there, we're going to solve 5 of your problems terrestrially, because we're going to get tons of clever people trying to solve this really hard problem.
Yeah.
And we will fix a lot of your things on Earth. So I think the benefits to the space industry, to the mining industry, are probably greater than the contributions, potentially.
Yeah.
And as an argument for working with the space and mining industries together.
Yeah, it's fascinating to hear all these, hurdles to solve one problem in space.
Yeah. And, trying to do all these things in a vacuum.
Yeah.
In a vacuum, without liquid water, high radiation, low gravity.
Yeah. So according to you, if we do succeed in extracting resources from the moon, what kind of impact could that have both for Earth and future space exploration?
I'd say for Earth, not much. Now, if you're talking about mining in space resources, virtually never are you talking about bringing stuff back to Earth, right? I think the only business case anyone's talking about at the moment is helium-3, which is good for fusion. Yeah. Some people are talking about bringing back things from asteroids, but for exploration, I think it's fundamental. The way to Mars over and over seems to have been shown to be the moon, right? So part of what we're arguing is, part of that way to Mars is to use the water on the moon to get to Mars. That's a finite resource that will only work for a while. You need to come up with alternatives. Asteroids are a possibility. But definitely we'll learn things on the moon. If you have a business you could run, like mining, that will mean you might be able to have a permanent presence onto there. Most of the work we do does not issue humans. Humans introduce too many problems. Even on Earth, right?
Yeah.
If you're trying to increase the technology in a ploughing, a piece of ploughing equipment, ploughing up and down, the most expensive thing about your tractor is the cabin with its air conditioning and seats and all of the mechanical devices that are made for a human to use. If you can take the human out of it, that thing becomes a lot cheaper, right?
Yeah.
And guess what? Someone doesn't have to drive a tractor up and down all day. So if you can get away without humans, that would be good. And whether exploration without humans is as important as exploration with humans is a discussion for another day, probably.
Yeah, this is where it really becomes more than just engineering.
Well, human factors, you mean?
Yeah.
Yeah, well, I mean, many people argue that human factors is also engineering. Yes.
So now I want to move into something really exciting, taking ideas beyond research into startups. You have mentioned having ideas for space startups. What inspired you to take that step into entrepreneurship?
Yeah, well, I'm not claiming to be an entrepreneur or being any sort of leader in entrepreneurship, but 2012, Jason Held, there weren't that many people working in space. So Jason Held, who runs Sabre Astronautics, and I was just sitting around complaining about things, and it was his idea. He said, look, why don't we set up a space business accelerator, startup accelerator, which we decided to call Delta V, and we brought some other people in. And that was really Jason's idea. Jason's the entrepreneur. And what I recognized in retrospect was this was really the way to go. The space industry did not really exist as an industry. There were outposts of big primes here, but they really had no autonomy. If you wanted to do something with them, they had to get permission from head office, and there wasn't a lot of research being done by any of them or anything like that. So we sort of had to bootstrap our industry out ourselves. And, we would be saying all sorts of things at that time. I was arguing, oh yeah, so we could do launches, we could do this, that. Not really believing it to be the case, but ultimately it has turned out that way. We do have spaceports, we do have rocket makers, we do have satellite builders, we do have satellite purchasers, ground segment, people who deal with all the regulations. It's like a little mini industry has, and bits and pieces of it covering all bases, has come up from that time 15 years ago when there was nothing here. And I've been quite amazed at that. And I would like someone who's good at business, not me, to try and explain why that happened and how it happened. I mean, one of the reasons, again, is good people who, I know most of them since they were one-man bands, but one-person bands. They were good people who have spearheaded those companies. And one of the things I would like to test is, my hypothesis is that Australian space startups are succeeding at a rate higher than other startups in Australia, and Australian space startups are succeeding at a rate greater than space startups elsewhere. There's something, and it may be just a moment in time, that the last 10 years, because we had no industry and we had to, if you wanted to work in space, you had to do it yourself.
Yeah.
And that's not the case now. So you can actually pop out of the end of the university degree and go work for here or wherever. Yeah. So yeah, I mean, I think the space startup business in Australia is a really interesting topic. And there's something special about it, and I'd like to know. I want someone to explain it.
Yeah. Firstly, to talk on Jason Held. I had privilege of meeting him recently, I had an episode with him.
You had an episode with him?
Yeah.
Oh, an episode of your podcast.
Yeah.
Right.
Yeah, I had podcast episode with him. He's an amazing person. The way he explains, talks out on anything is like he creates that curiosity and interest.
I think he's quite fundamental to this, to the success of the industry recently. And I think part of it is down to his personality.
Mm-hmm.
One thing which he was really good at was sort of helping others and and the industry at that time was very collaborative. Everyone was trying to help each other, maybe because everyone's in the same boat. And again, I don't know whether that's necessarily the case now as all the companies got bigger, whether the smaller companies collaborate with each other, or probably within the hubs like at Cicada and so on.
Yeah.
That probably is happening.
Yeah, he's a wonderful person I have ever met.
Oh, Jason.
Yeah.
I'm sure he'd be glad to hear that.
So I think, secondly, about you, your transition from research to, real world impact is a big one. And I wish you all the success and lot of curiosity. So I don't know how we are keeping up that curiosity, energy in the space industry from quite long time. You started it I think before anyone started working on the technologies, those are non-existential, right? So I think you worked on many projects from scratch.
Well, yeah, you don't get to my age without having done something, yeah.
So how old are you?
Just about the right age to retire.
Okay.
What I'm going to do, we'll see.
Yeah. So your experiences, I think, really shapes the technology you're intending to work on. Yeah. So for space startups, funding is often the biggest challenge. Yeah. What do you see as the biggest hurdle in space funding, especially here in Australia?
Yeah, look, I think that is a time-related question. So the answer now is not the same answer as 5 years ago, is not the same answer as 10 years ago.
Yeah.
So around that time when we were trying to get the agency up, people would not invest in space in Australia because those two things did not work together. Space in Australia was the wrong thing. And so you trying to get investment at that time was really difficult. Startup investment at that time was more difficult anyway, and space was quite peripheral. Yeah. Then with the setting up of the agency, I think to some extent, the agency didn't invest so much itself, but it was a signal. It was a signal to people outside and inside Australia that yes, we are now going to start doing space, and it sort of gave permission to some of the investors to invest. Now, also because of this thing where I'm saying they're relatively successful, we saw that a number of these startups got their investment and then went on with it, and so there's now a track record, so you can look back and say, look, investing in space in Australia is okay because the companies go ahead and well. One of my hypotheses that I'm looking to test is that these successful startup companies in Australia do not have the government as their, certainly the civilian part of the government as their prime customer, right? So you look at how space works elsewhere, where you've got these big agencies, big primes or whatever. The primes are sort of quite parasitic, and it's just there's lots of government money just being sort of handed over. That's not the way it works in Australia. These guys are out creating customers in a much more commercial, having a much more commercial approach, and there's multiple of them doing it. Now, so they don't have the government as a big customer now, but pretty much all of them had some sort of government help at the beginning.
Yeah.
So what I would like to see, I mean, I have to do the work, but if I can make the conclusion to that work now, is the government doesn't have to spend loads on expensive satellites. But if it spends some money at the beginning helping these companies get off the ground, they'll sort that out. They'll sort out a market for themselves and so on. But what that means is that the space agency needs to be proactive and looking to develop
Yeah.
new technologies, new approaches, new solutions. And the way that the current government is treating the agency is really very poor, and so probably the government's approach to the space agency is the biggest threat to successful space businesses in Australia at the moment.
Yeah, it's a very much different landscape compared to other tech sectors.
Yeah, exactly. They're pouring money, hundreds of millions, into a foreign quantum company, and yet the brilliant space people in Australia can't get it all.
What advice would you give to aspiring founders who want to launch a space tech company today?
Yeah, look, getting advice from the people who've been through the same process seems to be invaluable. The other thing is those companies which have succeeded, again, I think it's the majority. Let's not include the launch companies because this couldn't happen. But the others, they've come up with a good idea, they've pitched it around, but they've pivoted. They've gone to something. That's where the customers are. That's where the money's to be made. So come up with a good idea that'll get you through the door, and then listen, and be ready to pivot. Assume you're going to have to pivot. So assume that your brilliant idea is actually not what the customer wants, but listen to the customer so you can find out what they do want. Now, this is one thing I tell my PhD students as well when they come to me with some results. I said, I'm assuming that they're wrong, and you should assume that those results are wrong as well. So you should prove to yourself that they're right, and then you have proved to me that they're right.
Yeah.
So just have your brilliant idea, assume it's not going to make money, but milk it for everything you can get.
Yeah, this is something a lot of our listeners will really value.
Yeah, make money.
Yeah.
I'll give you my postal address. You can send me cash.
Oh, yeah. So as we start to wrap up, I want to take a step back and look at the bigger picture. If you could wave a magic wand and solve one major problem in space exploration, what would it be?
The big internet constellations, Starlink in particular, but the others that are coming behind it, they are likely to cause big problems. I mean, if that continues, space activity will probably have to stop because you won't be able to get past them on the way out.
Yeah. Okay. Considering I want to start a startup on working this problem of space debris in the future, what advice or what suggestion would you give me?
Well, same thing. Come up with a great idea. Like, there was one, just like, for instance, the one idea I heard about how to deal with space junk is you fly a spacecraft up there, which effectively has a big baseball mitt or something, right? Which is able to catch things that are moving in high speed. So it catches them, and then that energy of what you've just captured is also captured by this satellite, the Orion, and then that allows it to move on to the next one or whatever, and it'll deorbit itself at the end. I don't know where the idea went. I've never heard of it again, so there's something fundamentally wrong with it, right? But come up with an idea that gets you through the door, like the advice I was given before. But be imaginative.
Yeah, that's a powerful one to think about. Yeah. How do you see the Australian space ecosystem evolving over the next decade?
The space ecosystem.
Yeah.
Uh, yeah, look, where we are now
Mm-hmm.
is that we have a lot of these companies that have established their independence. They're just going about their business. I think the rate at which we advance as a sector,
Mhm.
I think each of those companies is likely to establish themselves, and so that we will have a space industry which looks like a space industry. But I think the main trying to find the right word, but the main factor that will affect it is to do with the space agency. I mean, I think that's the major weakness at the moment, where we need an agency which is really driving our Australia's space interests in a proactive way. Now, I don't blame the space agency for any of this. This is specifically a government problem. I mean, Ed Husic in particular is at fault here. He's the one that did most of the damage in the first Labor government of this series.
Mhm.
And, you know, the education process that we went through 10 years ago to get the Liberals over the line,
Mhm.
to some extent we have to do it again with Labor.
It feels like we are at really important moment right now for people to tell people how important space industry is in Australia.
Yeah, but I don't think there's been a time when it hasn't been important.
Mhm.
It's to some extent also, though, as I said probably earlier, that, you know, things are looking a bit dull at the moment,
Mhm.
but they're still way better than they were 10 years ago.
Mm.
So there are these companies that are still hiring, whatever,
Yeah.
and all of that's happening independent of anything to do with the space agency. But I think in terms of growth and diversification, that's where the agency has to come in. And I think that's what this point in time is about, diversifying what we do in space.
And finally, for the next generation listening, what's more important, dreaming big or starting small?
It's not like not dreaming big. It's more like dreaming aggressively or in a focused way. You know, make sure that you pursue what you're doing. And this, more of this romantic language, oh, you can do whatever you want to do, right? You know, I dreamt big and I did this or whatever. The reason why we hear this sort of language, right, is they interview the winner of the 100 meters at the Olympics. Say, oh, how did you do it? Oh, I dreamt big and I got here. They don't interview the other 7,
Yeah.
right? They didn't win. They dreamt big. Why didn't they win? Dreaming big's not enough. You've got to work out what you can do
Yeah.
and do that.
Yeah.
In fact, I think dreaming big is wrong, because 7 out of 8 people in the Olympic final don't win, right?
Yeah. So, Professor Dempster, this has been such an insightful conversation with you, from your journey to GNSS innovation, CubeSats, lunar resources, and even space startups and funding. There's so much here for people to learn from. Thank you so much for joining us today on Spacefront Conversation. Yeah. And to everyone listening, if you enjoyed this episode, make sure to follow and stay tuned for more conversations shaping the future of space. Thank you.